prove the following trigonometric identity. So we have square root on one side, and it is square root of 1 minus cos x divided by 1 plus cos x. And on the right, we have the reciprocal trigonometric ratios, cosecant x minus cot x. So to prove whenever we have square root, it is important to use technique rationalization. Right? Rationalization, as I have already said, is to multiply and divide by the conjugate of the term which you want to rationalize. So here we'll try to rationalize the denominator, right? So the principles which we are going to use here is, if a plus b times a minus b is equal to a square minus b square, that's one, right? So that is what we are going to use, right? And also remember, cos square x plus sine square x equals to 1. So it can always be reorganized or rearranged to write what sine square x is 1 minus cos square x, or cos square x as 1 minus sine square x. Okay. So to solve this, we'll start with the left side, and we'll write the square roots as equal to square root of 1 minus cos x divided by square root of 1 minus 1 plus cos x. Now when we are going to rationalize it, then we'll multiply and divide by 1 minus cos x square root. Okay, so we'll do that. So rationalize means to multiply and divide by a conjugate. So the conjugate here is 1 minus cos x for the denominator. So we are rationalizing denominator. So on the top, square root of 1 minus cos x times square root of 1 minus cos x will give us 1 minus cos x. And in denominator, we have 1 plus cos x times 1 minus cos x within square root. So that will give us 1 minus cos square x. Correct? A plus b times a minus b is a square minus b square. Correct? That's what. And now 1 minus cos square x will be sine square x. So we'll replace denominator with sine square x, the square root of sine square x, correct? And now this could be written as 1 minus cos x divided by sine x, which is 1 over sine x minus cos x over sine x. So 1 over sine x is cosecant x, and cos over sine is cotangent x, okay, which is our right side. So we have proved left side is equal to right side. Hence, the identities are true.